to come, they can join the session in between. This is your yesterday's session. Okay, so yesterday we start with the backpropagation neural network. So basically, the purpose of understanding this thing is we need to understand this thing. Basically, the concept of hidden layer, why we are adding hidden layers, what are the impact of hidden layer on your neural network. That things we need to understand, because this thing already we had discussed in previous to previous lecture. So perceptron we don't need anything, but in backpropagation neural network we need hidden layers, and in hidden layer basically we are using to add non-linearity to the system. So this is the basic conceptual thing yesterday we had gone through. Okay, so yesterday at the end I had asked two questions. Really, many hidden layer included in the application neural network for any application. Application from, right. So basically, if somebody is telling that I want to increase my hidden layer by massively, I want to use 50 hidden layers. Somebody is telling I use 30 hidden layers. So what basically this hidden layer is going to impact in your system, that we need to understand. Right now, complete neural network theory, if you are understanding. Am I audible or not?
Yes, sir,
Yes, sir.
you're audible.
Okay,
Yes, sir.
thank you. You're just solving the problem. You're finding the best pair of your WNP. Means you're finding the weight in bias pair. This is our objective. Whatever you people are thinking till that, you're using neural network, you are training your neural network and finding the answer. You're just finding this thing, your weight in your bias, nothing else. Because if you change your weight and bias, accordingly, your separating boundary is going to change its orientation, angle, intercept, everything. Please understand this thing. So if I find it out this thing and this thing best, then I definitely had a good classification accuracy. So the first major issue, if we increase number of hidden layers, then your system is having problem of vanishing gradient. Yesterday, that's why I started this question. Though I know about it because we are having 5-10 minutes, and I started with this question. But if I increasing my number of hidden layers, we stuck in this problem. The problem name is vanishing gradient. One by one, we understand each and every conceptual things. If we talk about only gradient, your gradient is first order derivative right? Your first order derivative is your gradient, and basically we are vanishing your first order derivative. So where exactly is going to impact? If we consider our simple case, y is equal to wx plus b, and now we had having w and b. So if you want to, please understand, when you come up with your backpropagation neural network, this is your input, this is your hidden layer 1, this is your hidden layer 2, this is your hidden layer 3, and this is your output layer, right? Now when you are providing your input over here, you are providing the label with that input. This is your actual label, and whatever the label we are obtaining over here, this is your predicted label. So when you are coming to the solution, over here you are finding your delta E. Delta is nothing but is your error, is your actual minus predicted. This is your delta E. Now you are given some input with the label, and your neural network basically, whatever the random weight and bias you are initialized, it predicted one value for you. Now if you find it out the difference between your actual label of the class of that weighted and predicted label, you can find it out how much error you are having. Once you are finding out your error, you need to backpropagate that error. Backpropagate means now you need to update your weights and bias of each and every neural network, each and every hidden layer. The purpose of backpropagating is you need to change the values of W and B. Because if you cannot change the value of W and B, your separating boundary is not going to change. So it's definitely every time is going to give you the wrong answer. But now you are away from your actual answer, so now you need to update the weights accordingly. And if you update the weights indirectly, you are updating your separating boundaries. And when you're changing the boundaries, definitely next time you're going closer to your solution. This is the reason why we use the word backpropagation. Backpropagation, definitely we are backpropagating our error to the hidden layer. But here we are just updating our weight and bias, nothing else. We are not changing our architecture, not changing the number of neurons, not changing our number of hidden layers, but we just need to update our weight and bias. This is the preliminary principle we need to understand. What exactly we are changing. Though you are using your Python programming as your tool for implementation of neural network, at that moment of time, you people are not understanding this conceptual thing. वो internally कर क्या रहा है? आपने तो सब कुछ बना के दे दिया, function use कर लिया, but what exactly function is doing, you people need to understand. When the error is coming, why it's going back, what is doing exactly inside the network, we need to understand as a computer science people. So if we need to find it out, weight. So W new, W indicates your weight is equal to W old this thing is covered in your class or not? Am I audible?
No, sir.
Okay, thank you. This is your learning rate. This is your error. If I say is that कि अब हमारे अभी सेशन में 134 students है. If I ask you simple question, if all the student having same capacity of learning, सबकी same capacity है सीखने की?
No.
Yes, no.
No.
ओके, तो हर एक की कैपेसिटी में क्या चेंज होता है बेटा?
Grasping power.
एब्सोल्युटली करेक्ट, ग्रैस्पिंग पावर। कोई एक बार पढ़ के सीख लेगा, कोई एग्जाम से पहले 10 बार पढ़ेगा, कोई 15 बार पढ़ेगा, कोई तो सिर्फ एक बार देख के जाएगा और उसको याद रह जाएगा। ये आपने महसूस किया होगा अब तक स्कूल लाइफ और कॉलेज लाइफ में, राइट? हाँ तो बोल सकते हो। If you correlate your learning rate with your life, you people can understand it. Okay. So
Yes.
basically the range of the learning rate is between your 0 and 1. This is the range we need to take whenever we are using neural network. If suppose मैं ईटा की वैल्यू 0.98 लेता हूँ और मैं ईटा की वैल्यू 0.02 लेता हूँ, does it make any impact on our neural network? Please understand this thing. बहुत अच्छी चीज है, बिकॉज ये चीज समझ लिया तो आप डीप लर्निंग कम्युनिटी के 50% कंसेप्चुअल चीज सीख चुके हैं। उसके बाद सिर्फ आपको कोरिलेट करना है। डीप नेटवर्क मींस एनी नेटवर्क्स यू आर यूजिंग इन डीप लर्निंग आर्किटेक्चर। This is your contour plot and this is your global solution, or you can say that best solution. अगर इस फिगर को मेरे को दूसरी वे में ड्रॉ करना है तो मैं ऐसे ड्रॉ करता था। यहाँ पे मल्टीपल मिनिमास थे, but now we need to think about your contour plot, this, and here we initialize our W and P. So now if I am taking my eta value is equal to 0.98, means I'm taking my learning rate as a very high, right? So learning rate is nothing but it's your step size. ये पहला स्टेप हुआ, दूसरा, तीसरा, चौथा, पांचवा, छठा। प्रॉब्लम क्या होगा इस फिगर से ये समझना था, when your eta value is very high at the time turns to is the minimum. Means minimum means this is your global solution. I'm talking about that. Minima, or you can say that the global solution. इतना बड़ा लेंगे तो ये दिक्कत होगी। तो दूसरी चीज है, अब मैं इनिशियलाइज करता हूँ ईटा को 0.02. W and B are same, just I'm changing my learning rate of the system. 0.02 मतलब बहुत छोटा, बेबी स्टेप्स हुए। This, then this, then this, then this, this. दोनों में फर्क क्या मिला? अगर my eta value is very low, it requires more number of iteration to reach the number. बहुत बड़ा वैल्यू है तो क्या इम्पैक्ट होता है दैट यू पीपल हैड सीन. बहुत छोटी वैल्यू है उसका भी एक इम्पैक्ट है. So please try to understand. Lots of people every time telling you are tuning your hyperparameters in deep learning community. This all are your parameters. You are fine tuning that parameters. What is the best suitable values for learning rate? Please try to understand. Number of neurons in your hidden layer is also a fine tuning parameters for you guys. So if you people understand this all basic principle of neural network, then any person that created any neural network you can understand very easily. That's why I'm spending time for you guys. So now there's two things is clear with you guys. If you take your eta values very high or if you take your eta value very low. Any doubt?
No, sir.
Okay, good. ये फिगर हमेशा याद रखना. If you want to explain somebody, you don't need to write it down the statement, the below I had written. But you need, this is your contour plot. शायद कंप्यूटर ग्राफिक्स पढ़ा होगा तो ये सब कुछ प्लॉट देखा होगा आपने. So again we come back to this equation. Again I'm writing down over here. Now this is clear to you. This is clear to you, right? But if we increase the number of hidden layers, and basically your delta I is in terms of sometimes like this. This is your delta I, assume that. And now we are substituting this value over here. So W new equal to W old plus eta, and this 0.0008 and this is 0.2. Assume that this is the multiplicator. If you multiply these two terms, then this is W old plus almost 0. And if this term is almost 0, means your W new is equal to W old. This is not going to change. In when your W is not changing, means your separating boundaries is not changing. Mean there is no change in separating boundary, means there is no change in your performance. Please make clear statement over here. And if we talk about Bayes, if we write it down, the equation is similar to your weight equation. In this also, if this terms is almost 0, then your B new is equal to B old. Means we are not changing our intercept also, right? So this condition whenever exists at that moment of time, to increase number of hidden layer 50, 70, 170, 270. Anyway, this is your finishing gradient. We are not changing anything. Though principally you people are thinking that number of hidden layer we are going to increase, your performance is going to increase. If you want to see change in your performance at that moment of time, your both variables W and B should be updated. If your W and B updation stop, means Performance means in terms of your efficiency or accuracy, whatever you people are dealing with. Please try to understand. uh, Your neural network requires certain resources. This does not mean I can use the number of hidden layers. So this is the principal thing that we need to understand. How exactly the people had created the computer system for biological nervous system. Biological nervous system is your brain. If we had created, even if we talk about the things, अभी मेरे को किसने आंसर दिया था, उसका नाम जान सकता हूँ? The person who had given me the answer. Okay, किसको मेरी आवाज सुनाई देती है? सब मेरे को नाम चाहिए.
Yes, sir.
तुम्हारा नाम है सौम्य. ओके सौम्य, एक चीज है, मैं तो एक क्वेश्चन पूछता हूँ. सपोज आज आपने मेरे को देखा, आप बहुत अच्छे मूड में थे, तो आपने मेरे को बहुत अच्छा रिप्लाई दिया, आप मेरे सामने हो ऐसा. लेकिन कभी आपने अपने फ्रेंड से झगड़ा किया है और आप मेरे सामने आते हो. अज्यूम करना, दिस वेरी नाइस सिनेरियो टू अंडरस्टैंड योर ह्यूमन ब्रेन. उस टाइम मैं आपके सामने मिलूंगा, आपका रिस्पॉन्स सेम होगा या अलग होगा?
It will be different, sir.
करेक्ट. रीजन क्या होगा इट विल बी डिफरेंट?
Because of the event that happened in the past.
एब्सोल्युटली करेक्ट सौम्य. प्लीज एवरीवन ट्राई टू कोरिलेट दिस थिंग. मैंने सिर्फ अपना एग्जांपल दिया, दो मी एंड सौम्य नेवर मीट ईच अदर, बट दिस इज जनरली हैपन टू एवरीवन. जनरली हैपन टू एवरीवन. लेकिन आज तक वो चीज हमने कभी भी न्यूरल नेटवर्क में नहीं इंप्लीमेंट की है. हमने एडेप्टिव किया ही नहीं है. हमारे लिए अगर एक एग्जांपल अभी आया, बाद में आया, उसके बाद में आया, 10 दिन के बाद में आया, हमारे लिए वही रहता है रिस्पॉन्स. रिस्पॉन्स हम चेंज नहीं करते. कभी सीखना ये सारी चीजें. दिस इज द सीरियस रिसर्च पीपल आर डूइंग. इट्स नॉट लाइक दैट इफ यू हैड लर्न न्यूरल नेटवर्क मींस यू आर नोइंग ईच एंड एवरीथिंग. People are doing massive research on it. But first of all, if you want to do any research, you need to understand the domain. For you, the domain is your biological nervous system. Though I just taught you the human cell, you people might be thinking, sir, syllabus के बाहर की चीज पढ़ा रहे, हमको biology की क्या जरूरत है? But if you understand your biological knowledge, whatever the God had created, तब हम actual वो system को बना सकते हैं. If I abruptly started with this all the things, you people are never going to get the detail about it, what exactly your human brain is doing. एक सिंपल चीज, एक क्वेश्चन पूछता हूँ, क्या आप कभी झूठ बोलते हो? आपने लाई डिटेक्टर हमेशा देखा होगा, मूवीज में या चैनल्स में या वेब सीरीज में. देखा है नहीं देखा?
यस सर.
वो लोग करते ही है लाई डिटेक्टर में.
सर जो मतलब हार्ट रेट है और वो
हार्ट रेट और
करेक्ट जय, हार्ट रेट और वो है. म्यूट करने की जरूरत नहीं, हम कन्वर्सेशन कर रहे हैं, राइट? अब एक चीज सोचो कि सपोज सौम्या या जय ने किसी इंसान को नहीं देखा है, तो उनका रिएक्शन कैसा होगा? और किसी इंसान को देखा है लेकिन मैं पूछूं आप उनको जानते हो, तो वो मुझे मना करेंगे. उन दोनों सिनेरियो में उनके एक्सप्रेशन अलग अलग होंगे. यस नो? वो किसी बंदे को जानता था, लेकिन मैंने उसको बोला आप उसको जानते हो या नहीं, तो उसने मुझे बोला नहीं, मैं नहीं जानता. लेकिन आप चीज सोचो, जब भी आप कोई भी चीज देखते हो तो आपकी ब्रेन में एक पैटर्न क्रिएट होती है. आप ब्रेन का फोटो ले लो, आपको पता चल जाएगा. लाई डिटेक्टर इज बीन टोटली हाइपोथेटिकली. अब किसी को एंजाइटी इतनी है तो उसका पल्स बहुत बढ़ जाएगा, तो उससे इतना तो श्योरिटी नहीं कह सकता कि वो डिटेक्टर सही है या नहीं. लेकिन ब्रेन हमेशा एक इमेज जनरेट करता है, वो पैटर्न जनरेट करता है. वो नुकसान करता है ऑब्वियसली अपने शरीर को. इतने सारे स्कैन्स करेंगे तो हम अपने ब्रेन के, लेकिन हमने किसी को दूसरी बार देखा है तो द ब्रेन इज क्रिएटिंग द पिक्चर. प्लीज अंडरस्टैंड. एंड इफ यू वांट टू अंडरस्टैंड, क्रिमिनल में हमेशा ऐसा होता है, आप इसको जानते हो या नहीं जानते हो, उनका फोटोज दिखा के हम पूछते हैं, राइट? At that moment of time, if we are having such type of facilities, then definitely we can provide certain amount of solution. मैं इतना तो नहीं कह सकता 100% हम solution create कर सकते हैं God की तरह. But if you think about this, this is very nice from my point of view. पहली चीज मैंने जो बोली कि आप मेरे को देखोगे तो आपका एडेप्टिव होता है. रिस्पॉन्स क्या होता है? कोरिलेटेड होता है वॉट एवर द योर सराउंडिंग एनवायरमेंट इज. अगर आपने टॉप किया यूनिवर्सिटी में, उस टाइम पे मैं मिलूंगा तो आप सीरियसली बहुत अच्छा रिस्पॉन्ड करोगे, अगर आप मेरे को अच्छा मानते हो तो. नहीं तो हमेशा बोलोगे यार ये सर बहुत सड़ू है, लंबा लंबा पढ़ाते जाते हैं. यहाँ तक किसी को डाउट है?
No doubt, sir.
No, sir.
Okay. So now you got this answer. Why we cannot increase number of hidden layers abruptly? Because we are facing this problem. We are facing this problem and we had justified this thing over here. Even we need to focus on our learning rate. आप में से किसी ने भी अपने इंटर्नशिप के प्रोजेक्ट के लिए न्यूरल नेटवर्क यूज किया था? किसी ने भी? मेरे को पूछना नहीं है, सिर्फ हाँ या ना चाहिए आंसर में. किया था नहीं किया था?
No, sir.
नहीं किया है. तो किसी को करना है अपने फाइनल ईयर प्रोजेक्ट में? जबरदस्ती नहीं, खाली पूछ रहा हूँ, टेंशन मत करो.
Yes, sir.
Yes, sir.
अगर करना है तो बहुत सारी चीजें इसमें कर सकते हैं. दैट्स व्हाई आई टोल्ड यू, because in your syllabus we are going to head our deep networks conceptual things also, because first we need to learn your artificial neural network, then you are having your convolution neural network, all the deep network conceptual things. अब deep network की बात निकली है तो deep networks we are deep neural network. The deep in terms of you are having बाकी ये टर्म आपको आती है. Even you know the many hidden layers. Deep in the sense very deep network. If we can draw this thing, it's look like this. This your input. This 1, 2, 3, 4. ये सारी लाइंस आपकी हिडन लेयर्स हैं. This is your. This all are your hidden layers. मैंने लिख लिया, उसके बाद डिले आता है. Okay, so this is known as a deep. In terms of this is very deep. That's why they are given the name deep, and basically we are using neural network. That's why they are given deep neural network. And one more thing, if you people need to understand is, ये वर्ड सबने सुना है? Yes, no.
Yes. Yes, sir.
Good.
Yes, sir.
तो इसमें हम इनपुट देते हैं. Then second box was feature engineering. Or we can say handcrafted feature. Sorry. Or you can say the machine learning algorithm. And here you are having class label. This is basic procedure we are doing when somebody is telling I'm doing my project in machine learning. Application might be image processing application, data intensive application. So don't think about it. But this is very important thing you need to understand. I say feature engineering or handcrafted features means we are calculating features by certain procedure we are applying algorithms and all the things, but that procedure is done by us, not by the system. And the diagram, if I need to know about deep networks, what's the difference between these two things? This is your input, this is your deep learning algorithm, and this is your class label. Right? And now we're just going to open this box. You might be get some idea. This is your input. This box itself finding the features. Then you are having your and after that you are having your class label. So basically whatever this thing is there is done by us. Now it's done by your deep learning algorithm, not by specific programmer or coder. Even the upcoming future, you people are having knowledge about this types of learning. In that we had written supervised learning, unsupervised learning, reinforcement. But nowadays, which learning is popular is being the self-supervised learning. So people are doing research over here. Though you people are learning this thing, I will give you brief introduction whenever we are having time. But I'm very much interested in this word self-supervised learning. And some of you having interest, then we can create a group and we will discuss such type of thing. Because you people are in fifth semester, and if you're learning this thing at this semester, definitely you are having great amount of scope. People are doing this thing. This research community is seriously following self-supervised learning. If you talk about supervised and supervised, people telling this has been outdated. We are focusing on self-supervised learning. So if the community is doing, we even need to know about it. It's not like that if we are not updating ourselves, you are just updating it at the point of view of the programming language or tool. You need to understand the conceptual thing about it also. So this is very nice conceptual things. Now we started with deep learning things. The second network is your convolution. It's been convolution neural network. Please understand this thing. Every time whenever I am writing this word for you guys, now you are having the awareness about neural network. So whatever word precede your neural network, you need to understand that thing and how they be exactly fit that word to the neural network. That's the important thing. It's not directly you jump on convolution neural network, you're learning something new. The basic conceptual things about neural networks remain same throughout. You're going to read any article, literature, anything. So that's why we had spent this much amount of lecture in neural network understanding. After that, if we are having something, you can directly correlate it that thing. Got the point? Now, first we need to understand what do you mean by convolution. Am I audible?
Yes, sir.
Sir.
Yes,
Yes, sir.
sir.
आवाज कटी किसकी? Okay, good. So you don't need to focus right now on your neural network portion. Anyone had heard about this word convolution? Anyone had heard about the word convolution? होता क्या होगा convolution neural network? At least if you're people in 5th semester student, sorry. So definitely you have heard this word convolution neural network, and it's providing good amount of solution to you guys. And on the web or in Google or Colabs or wherever you are finding out, you people find it out the code for convolution neural network. रीजन क्या होगा कि मुझे ये करना चाहिए? बहुत अच्छा है इसलिए मेरे को करना चाहिए.
It's a
Because I'm not.
mathematical operation in which we multiply two matrices and then add
मैं
the
वापस बोला.
elements. It's a mathematical operation in which we multiply two matrices and then we do sum of the elements.
So in simple language, if I don't need to narrate it, multiplicative addition. But why we are using convolution? This is the basically mathematically justification that what exactly convolution is doing. But if I want to narrate it out, what do you mean by convolution? आज हमको इसका आंसर नहीं देना. Already we are completion of our lecture. So in the next lecture we are going to discuss about convolution neural networking, how exactly the convolution is neural network is finding feature itself and how it is applying your classification algorithm. So it's very useful for you guys at that moment of time to understand this thing, how exactly they people are calculating and how the handcrafted feature has been calculated by the user. Okay, thank you. You can leave the meeting. Okay, thank you so much.
Thank you, sir.
Thank you, sir.